This is problem 3 for homework 7.1. Determine whether the given set is a subspace and justify. A. S is the subset of all 3×3 diagonalizable matrices. If two diagonalizable matrices are added up then together, then the result may not be a diagonalizable matrix. Here's a counterexample. If we have 2, 1, 0, 0, 1, 1, 0, 0, and 0 here, which is a diagonalizable matrix, and we have another one which is -1, 0, 0, 0, 0, 0, 0, 0, and 1. So when I add up them together, I have 1, 1, 0, 0, 1, 1, and 0, 0, and 1, which is not a diagonalizable matrix. So it shows that it's not going to be closed under addition. It is not a subspace. B. S is the subset of all 2×2 matrices, where A11 plus A22 is equal to 0. Since A11 is equal to negative A22, according to the condition here, we can substitute A11 with negative A22. So if we have a matrix A is equal to this, and matrix B is equal to negative B22, A, B12, B21, B22. We can prove it's closed under addition by doing A plus B should be equal to negative A22 minus B22, A12 plus B12, A21 plus B21, A22 plus B22. Since the diagonal elements are summed to be equal to 0, so A plus B is still a matrix in S, so it's closed under addition. Also, we can do C times A, where C is the real scalar. So it's going to be C times negative A22, C times A12, C times A21, C times A22. Since negative C times A22 plus C times A22 will be equal to 0, then C times A, this matrix, will also be inside S, so it's closed under scalar multiplication. Since the 0 vector here is the 0 2×2 matrix is inside S, we can make the conclusion that S is a subspace. C. S is a set of all square matrices whose traits are equal to 1s. If we have a matrix A inside S, then trace for that matrix A will be equal to 1. And we have another matrix B also inside S, so trace B is also equal to 1. We have a property for the trace. Trace A plus B is equal to trace A plus trace B. So it's going to be equal to 1 plus 1, which is 2. So since trace A plus B is equal to 2 instead of 1, then it's not closed under addition, which means S is not a subspace. D. S is all the P3 polynomial functions whose first derivative is a constant. If we have P and Q inside S, and we know that the first derivative of P can be equal to C1, and Q has also a constant first derivative, C2. We can show that P plus Q has a first derivative which is equal to P prime X plus Q prime X according to the polynomial properties. So here, since P prime X is equal to C1 and Q prime X is equal to C2, the first derivative of P plus Q function is equal to C1 plus C2, which is a constant. So it's closed under addition. Then we can show that it's closed under scalar multiplication as well, because if we do CP, the new functions, first derivative, then it's going to be C times P prime X, which is equal to C times C1. So it's still going to be a constant. So the new function CP has first derivative which is equal to a constant. So the set is closed under scalar multiplications as well. Finally, we can find P is equal to 0, which is the 0 polynomial is inside the S. Thus, this S is a subspace.